In this lecture, we are going to discuss a few examples about the delta modulation. So let's start from the first example. A linear DM is designed to operate on speech signal which is limited to 3.2 kHz. The DM uses following specification. Sampling rate is equals to 10 times Nyquist rate and the step size is 100 millivolt. The modulator is tested with the 1 kHz sinusoidal signal. Determine the maximum amplitude of the test signal required to avoid the slope overload distortion. So from this information you can see the given data. The first one is 3.2 kilohertz, which is the maximum bandwidth of the signal. The sampling rate is 10 times the Nyquist rate, and you know the Nyquist rate is 2 times the bandwidth, that is 3.2 kilohertz, and the step size, which is 100 millivolt, and the sinusoidal signal or the FM is 1 kilohertz. This is the given data. So you use that given data to calculate few more informations like the sampling rate, that is 10 times the Nyquist rate, and the Nyquist rate is 6.4 kilohertz. 10 times 6.4 kilohertz is equal to 64 kilohertz. To avoid slope overload, so that is the condition that we have derived already in our previous session. So that AM should be less than or equals to delta multiplied by the sampling rate divided by 2 pi FM. So if you use all the values in this equation, so like here the delta is 100 millivolt, 110 is minus 3 multiplied by f of s, so sampling rate, so that is 64 kilohertz, so 64 multiplied by 10 raised power 3, 2 pi into fm 1 kilohertz, 1 in 10 power 3. So this 3 will be cancelled with that 3, and this 2 divided by 50, so that is and multiplied by 10 raised to minus 3. So using your calculator you can see that the value of the amplitude am is less than equals to 1.02. So this shows that this is the value required to avoid the slope overload. The second example, so we need to do a few more examples so that we can better understand the delta modulation. In this example, find the minimum sampling frequency f of s minimum to avoid slope overload when the signal is x of t is equals to cos 2 pi 800 t and the step size delta is zero point 0.1 volt. So the given information is the AM amplitude is 1 volt, FM is 800 hertz, and the step size delta is zero point 0.1 volt, and the signal, that is xt, cos 2 pi 800 t. So we know the condition to avoid slope overload. AM should be less than equals to delta f of s divided by 2 pi fm. We need to see the minimum sampling frequency, so that is why you can rearrange equation A in term of f of s. So the equation looks like this: am multiplied by 2 pi fm divided by delta. So all the values are given, so if you use all the values here in this equation, so you can see am is 1 volt, 2 pi is constant, fm is 800 hertz, and delta is zero point 0.1. So the answer is 16800 multiplied by 2 is 1600 pi, then multiplied by 10, the answer is 16,000 pi. So this shows that to avoid slope overload, the minimum sampling frequency should be at least 16,000 pi or greater than that. Let's do one more example so that we can better understand the delta modulation. In this example, the input to a linear delta modulator is a sinusoidal signal. So this is the information whose frequency can vary from 200 Hz to 4000 Hz. The input is sampled at 8 times Nyquist rate. 8 and then Nyquist rate means 2 times the bandwidth. The peak amplitude of the sinusoidal AM is 1 volt. So there are three cases in this example that you need to determine. In case A, determine the value of the step size. You need to determine the value of delta in order to avoid slope overload when the input signal frequency FM is 800 Hz. All the other information is given. And then case B, what is the peak amplitude of the input signal to just the overload the modulator. So when the input, so it means that to occur the overload, you need to see peak amplitude to occur the overload when the input signal frequency is 200 Hz. And case C is the modulator overloaded when the input signal frequency is 4 kHz. So for the solution, all the information like FM is given, bandwidth is also given. Nyquist rate is 2 times the bandwidth, that is 8000 Hertz. Sampling rate is 8 times the Nyquist rate, so 8 multiplied by 8, 64,000 Hertz. Amplitude is 1 volt. And for case A, you need to see the delta step size if the slope overload, like if the signal frequency FM is given, which is 800 Hertz. So to avoid slope overload, we know the condition in term of delta. So delta is greater than equals 2 pi am fm divided by fs. Using the values 2 pi am 1 fm is 800, fs is 64,000. So you can see, so 2 multiplied by 8, 16, 16 fours are uh, 64, so that is by 4. So these two zeros cancel with these two zeros, and the remaining is this 0. So the delta must be greater than or equals to pi by 40. For case B, you need to see the slope overload. You need to calculate the value of AM so that to occur the slope overload. If the some modulating frequency is given, that is 200 Hertz. So we already know to occur the slope overload, delta is less than 2 pi am fm divided by ff. So you can rearrange this equation in term of am. So a for the am is bigger, greater than delta ffs divided by 2 pi am or divided by 2 pi fm. So you can use all the values. We have already calculated delta, which is pi by 40. So it is written pi by 4, but actually this is pi by 40, pi by 40. So multiplied by f of s, so which is 64,000, and then 2 pi multiplied by f of m, which is 200. So 20 cancel out with these two. 4 multiplied by 2, pi will be cancelled with that pi. 4 multiplied by 2, 8. 8 multiplied by 2, 16. 16 fours are 64. So that is why the answer is AM is greater than 4 volt. For C part, Fm was given, and then you need to see if the modulator is overloaded or not for the given modulating frequency f of m, which is 4 kilohertz. So delta, so f of s divided by 2 pi f of m. We know the value of the delta, which is pi by 40 multiplied by 64,000 divided by 2 pi, and f of m in this case is 4,000. So using the calculator, you can see this ratio is equal to 0.2. So zero point 0.2 is less than 4 that you have calculated in the previous example. So it shows that no slope overload occur at FM equals to 4000 or 4 kilohertz. So that's all for this session. So we have done many example in our last session as well. So you can subscribe our channel so that you can keep in contact with our latest videos. So if you have any question, you can ask in the comment box. Thank you for watching the video.